So on this video right here, we're going to be doing the odd questions. Actually, let's do the even ones on this one. So let's jump to number 2. And what they want you to do is check and see which of the following coordinates are answers to that inequality. So you have to remember, so the x value is 6, the y value is 3. So if you plug in the 3 for y, it's going to say 3 is greater than or equal to 6 for x, and then plus 3. So if you do the math, it'll say 3 is greater than or equal to 9, and that obviously is false. So this is not a solution to that inequality. So you guys need to just go through and test every one. I know it takes a while. So let's do the next point. The x is negative 3, the y is 2. So if you plugged in the 2 right here where the y is at, it'll read 2 is greater than or equal to x, which in this case is negative 3, plus 3. And when you do negative 3 plus 3, that's 0. And you do have a true statement on this one. 2 really is greater than or equal to 0. So this one is definitely a solution. So circle that one, cross out the other one, and you go through and you do this for all of them, right? So x is 3, y is negative 2. So instead of y, you would put negative 2. So you're going to have negative 2 is greater than or equal to x plus 3. X is 3 on this coordinate plus 3. So right here it would say negative 2 is greater than or equal to 6. And that is a false statement. There is no negative number that's greater than a positive number. So that did not work. So this one did not work. It's not a solution. And if you try the last one, 4 on x, right here, 4 right there, 4 plus 3 is 7. 3 on y, it'd say 3 is greater than or equal to 7, which is false. So that one would not work either. So the only one that works here is negative 3, 2. That doesn't mean that there's only going to be one answer on each of these. Sometimes you might have more than one answer because it's a whole area of answers when you're dealing with inequalities. Maybe all of them are answers. But anyways, there's only one answer right here on number 2. Let's jump to the next even question, number 4. And we need to graph these inequalities. Now, we learned how to graph yesterday. Step 1 is to get y by itself. You want y equals mx plus b. There's no equals. There's an inequality here. So let's get y by itself. We're going to start by getting rid of the minus x by doing the opposite, plus x. And what you do to one side, you do to the other side. And you will have 2y is less than, and let's rewrite this. Instead of negative 4 plus x, I want to write a positive x minus 4. And of course, the value in front of x is an invisible 1. So I still need to get the y by itself. And right here you have a 2 times y. You don't want the multiplication of 2 in front of it. So you're going to do the opposite, which is dividing by 2. And you divide everything by 2. So that way it cancels. And now you have your slope-intercept form inequality. So you have y. You do not flip it because you did not divide by a negative. You do have the slope of 1 divided by 2, rise 1, run 2. There's an x right next to that slope. And at the very end, you have your plus b, which in this case is a minus 2. So there's your y equals mx plus b equation. Actually, inequality, not equation. But now we know how to graph this thing. We start by going to the b value. It crosses at negative 2. So if we go to negative 2 on the y-axis and put a dot right there, we know that the line crosses right through there. Now from that point, from this point, you need to rise and run according to your slope. So you're going to go up 1 and over 2 and put a dot right there. And of course, you could keep going up 1 and over 2 to extend your line as long as you'd like. And you could go backwards to extend it the other way. So that was the first 2 steps. I guess part 2 or step 2, you still need to decide if it's a solid line or a dotted line. What do you guys say? It's definitely dotted. If it had a solid line underneath the inequality, then it would be a solid line. But it does not have a solid line, so it's not going to be a solid line. It's going to be dotted. So you got to put some more dots in between your dots. And then you have to shade in either one side of the line or the other side of the line. And how do you do that? You do that by testing a point. 0, 0 is the easiest to test, unless the line actually crosses through 0, 0, then you wouldn't use 0, 0. You could use any point you want. But check out how easy 0, 0 is. If you take the 0 on the x and put it right there, and take the 0 on the y and put it over here, then you would have 0 is less than 0 minus 2. That would say 0 is less than negative 2. Okay, and that is a false statement. So if I did plug in a 0 right here and a 0 right there, it would say 0 is less than negative 2. And we all know that that is false. 0 is greater than any negative number. So we know that this origin point 0, 0 does not work. That's not an answer. So where must my answers be at? On the other side, on the bottom. So you'd shade in all this. And yes, you're going to have to shade on the quiz that you take on this section tomorrow. So there's many opportunities for mistakes, right? Like you might mess up graphing the actual line. You might mess up on this algebra part when you get y by itself. You might mess up on the shading if you test the wrong points or if you don't test it correctly. So you have to be very careful when you graph these. It's pretty easy. It gets easier if you practice. Let's try the next even question, number 6. If I wanted to get y by itself right there, what would I do? Divide by 3. Divide everything by 3. This by 3, this by 3, this by 3. My new slope-intercept form inequality is going to be y. Do I flip the inequality or keep the inequality? Keep it. Greater than 2 divided by 3. I can't do it with the x on it. And negative 3 divided by 3 is negative 1. Let me use colors here to show you that my slope is rise 2, run 3, and my y-intercept is a negative 1. Okay, so it crosses the y-axis at negative 1, and from that point I'm going to go up 1, 2, and over 1, 2, 3. Put a dot right there. Now, is this line going to be solid or dotted? Dotted again. So let's put some dots between the dots. Now, notice that I would like to extend it this way. Going this way, it's pretty easy. Just put a couple more blue dots right there. But in the opposite direction, it'd be a good idea to use that same slope pattern, but backwards. Instead of going up 2 over 3, let's go backwards 3. 1, 2, 3, and down 2. 1, 2, 3, and down 2. That way you could get to that next coordinate. And you could do the dotted line. So you have your dotted line all the way through from one side of the graph to the other. Now you want to shade, and you're either going to shade in the top or the bottom, depending on where the answers are. So if you test the point 0, 0, will it work? It's as easy as this. Take 0, put it in place of the x. Take 0, put it in place of the y. So you'll have 0 is greater than 0 minus 1. So you'd have 0 is greater than negative 1. What do you guys say about that? Is 0 greater than negative 1? Yes, it is. 0 is greater than any negative number, right? Okay, now how about this? You don't have to plug it into your slope-intercept form inequality. You could have plugged in 0, 0 to the original equation. A 0 right here on the y, a 0 right here on the x. And you could have said 0 on this side is greater than 0 minus 3 is minus 3. So you'd have 0 is greater than minus 3. That's a true statement also. So you could plug it into your slope-intercept form that you modified it to, or you could plug it back into the original. It's still, you're testing 0, 0, and if it works, then it is an answer. If it doesn't work, it's not an answer. That means that your answers are on the other side. So right here we saw that it did work, so I am going to shade in the side that the 0, 0 is on. So I shade in the top part. What do you guys think? Now I want you to test the point 0, 0 always. Unless your line crosses through 0, 0, then I would like you to test a different point. However, there is a shortcut. I think it's time for me to explain the shortcut to you. Guys, what does this say when it's in slope-intercept form? What does it say? Y is what? Greater than, right? And greater than is going to be above or below? Above, right? So when you have y by itself and it's greater than, think about this. On your y values, you want the ones that are greater than, which means above. So that's why we shade in above. So that's a shortcut. Instead of testing 0, 0, I still want you to test 0, 0 or test a point, right? But the shortcut is, let's go back to number 4 over here. The shortcut is what does it say right here? Y is what? Less than. And less than, is that above or below? It's below, so notice I shaded in below, right? So that's like a shortcut. And yes, you could do that on the quiz. I would still like you to test 0, 0 though. Let's jump to number 8. Right here, this one's not ready to graph yet. What do I do? Y equals mx plus b. Okay, so let's get rid of that 6 by subtracting 6. Subtracting 6, you will have y is greater than 2/3 will be your slope with an x on it. And 5 minus 6 is a -1. So I already put the slope in blue and the b value, the y-intercept, in red. So it crosses the y-axis at -1. There it is. From that point, I'm going to rise and run according to my slope. Rise 2, run 3. If it would have been a negative slope, then I would have gone down 2 over 3. But it's a positive 2 over 3. So I go up 2 over 1, 2, 3 and put a dot right there. And you could go backwards. You could go over backwards 3 and down 2, backwards 3 and down 2 to extend it to the other side. Now, is this going to be a solid line or a dotted line? Man, all the even ones are dotted. That's weird. But here we go, dotted lines. Final detail, I need to shade. I either shade in above or below. What do you guys say? Just based on the shortcut I showed you. Above, right? It says y is greater. So the greater values on y are up here, aren't they? The lower values on y are down here. So if we say y is greater, then we'd have to shade in above. So let's shade in above. Now, what do I really want you to do? I don't want you to use that shortcut. I want you to test 0, 0. So if we were to test this point, I already know it's going to work. But if I were to test the point 0, 0, and I plug in 0 for x right there into the original, and 0 for y, you're going to have 6 is greater than 5. And 6 really is greater than 5. Right? If you had a 0 here and a 0 there, it'd say 6 is greater than 5. So 0, 0 is a true statement. So it does work. So you do shade in that side that it's on. Let's jump to number 10, which is not there because I modified this worksheet. I added 4 more questions. So let's jump to the even ones on those extra questions that I put at the bottom. Number 12, they want you to write the linear inequality of the following graph. So what could we say about this inequality? Well, if we want to write an equation, we need 2 things to write an equation. We need a m value and we need a b value. Isn't that right? Now, what is the m really? The slope. Now, to find the slope, we need to look at the line from left to right and we want to pick some clean points. Now, what do I mean by that? Right here I have a clean point, right? But this is not a clean point. That's not a clean point. Tell me when to stop. Let's say from over here. Where's the clean point at? Tell me when to stop. Right there. That's a clean point, right? That is the coordinate -1, 1. So let's all put a dot at -1, 1 and also at the y-intercept, which happens to be a clean point. It won't always be a clean point, but it is in this case. So let's compare those 2 dots to find the rise over run. How do we look at lines? We look at them from left to right. So from this red dot to this red dot, am I going up or down? Down. So it's going to be a negative rise. How much do I go down? 1, 2, 3. So -3 is my rise. And what's my run? 1. So if you go down 1, 2, 3 units and you go 1 to the right, then it's a 1 as a run. So there's your slope. You could just say -3. Now, how about your b value? What's your b value? Where does it cross the y-axis? -2. So if you know your m and you know your b, you could write your y equals mx plus b equation. However, it's not an equals, it's an inequality, right? So we have y. I'm going to leave it blank right now, but I'm going to put the -3 for my slope with an x on it and a -2 at the very end for my b value. So if it were an equation, I would say y equals mx plus b. But it's not an equation, it's an inequality. Now, is this a solid line or a dotted line? Solid. So we know for sure that it's going to be an or equal to. So I'm going to put one of these lines right there. Now, the question is this. With regards to y's, am I shading above or below?
Above.
Check it out. Tell me when to stop my pen. Tell me when to stop. Stop. Okay. This is all above or below the line?
Above.
Really?
Below.
It's below the line. Check this out. Or how about this? Let me ask you this. Let me put a dot on the line right here. You see this red dot right here? Is the shading directly above this y value, or is it directly below this y value?
Below.
It's below. How about this one? Is it directly above or below? Below. It's below. So the shading is below. So that means that right here, see, y is what? Greater than or less than? Less than, because the shading is below. It's that shortcut I showed you, but backwards. All right? So less than or equal to. Y is less than or equal to on that one. Does that make sense? No? A little confusing? Let's try another one. Wow, this is even going to be more confusing. Do you guys remember how to graph either horizontal lines or vertical lines? There's something special about those. What's a special detail about those?
This one is going to be x equals.
X equals, because if you have x equals, it's going to be a vertical line, right? Yeah. Okay, perfect. Now, what is that value of x where that vertical line crosses through? Negative 1 and a half, right? So here's 0, there's negative half, there's negative 1, there's negative 1 and a half, right? So we know that if it were an equation, a regular equation, it would be the equation x equals negative 1.5, or you could say x equals negative 1 and 1/2. However, it's not an equation. It's an inequality, right? Now, there's shading involved, and there is no above or below because we're not talking about y values. We're talking about x values only. So let me ask you this. On the x values, would you say that the shading is less than that negative 1/2 or greater than that negative 1 and 1/2? It's greater than that negative 1 and 1/2. So the correct inequality for this graph would be x is greater than negative 1.5, or x is greater than negative 1 and 1/2. Those are your inequalities that represent this graph right here. I hope that makes sense. Oh, why did I do 13? We were supposed to do the even ones. Oh well. Might as well do all of these right here. Number 14. Do I have a slope? What is my slope? Oh, just my slope. Like, how much do I rise? How much do I run from one point to another point? And you pick clean points like those. What's my slope? Do I rise or do I drop?
You run once.
You run one, that's for sure. But do I rise or do I drop? Drop. How much do I drop? 3. So negative 3. So your slope is negative 3. How about your b value? Where does it cross the y-axis? Crosses at 0, right? So now that we know our m and our b, we could write our y equals negative 3x plus b. That plus 0 is not necessary. Now, it's not an equal sign, though. It's an area. With regards to y's, is the shading above or is it below? Below, right? Any point you pick, it's below. Any point you pick, it's below. So it's all below, and it is a solid line. So if it's below, what kind of inequality will I have? Below. Less than or equal to, because it is solid. If it were above the line, then it would be greater than or equal to, because it's solid. So all you really need, if you're taking the final, this is what you're going to see. You're not going to see the plus 0, but you are going to see the y is less than or equal to negative 3x. Let's try number 15 here. Could somebody tell me the m value? Picking 2 points. Rise over run. Here's 1 point, here's another point. How much do I rise? Rise 2? Over 1, perfect. And what about the b value? Where does it cross the y-axis? 2. Okay, so what about my slope-intercept form? If it were an equation, I would write y equals, I'm not going to put equals because it's an inequality, but I will have a mx plus b a 2x plus b. All I need is my inequality now. So what kind of inequality am I going to have right here? A greater than, less than, what do you guys say? Less than, absolutely. Why less than? Because it's shaded below your line, right? Now, do I need an or equal to on this inequality?
No, because it's a dotted line.
No, because it's a dotted line. If it were solid, then yeah, you'd put a solid line underneath it, but it's not there. And that's it, guys. This was a long video. I'm sorry. But if you haven't finished this worksheet, you need to go back and do all the odd questions. Go for it. Which, by the way, there will be a video explaining the odd questions.